Today's notes are on arson and fire investigations. So some vocabulary words for you related to the chemistry of fire. So fire is a rapid oxidation reaction that involves a combustible material. And if you don't know what the word oxidation means, oxidation is the complete or partial loss of electrons or the gain of oxygen. Combustion reactions that you may remember from chemistry are oxidation reactions that involve oxygen and produce flames. Heat of combustion is excess heat energy, and exothermic reactions, another chemistry term you might remember, are chemical reactions that release heat. So all of these terms are related to fire investigations. Now, there is the fire tetrahedron, and tetra means four, so it's a four-sided shape, and that is because there are four ingredients that are required to start a fire and keep it burning. It used to just be called the fire triangle, but that was just to start a fire. They added the fourth element for the and keep it burning. That is oxygen, fuel, heat, and a chain reaction. Chain reaction is what was added as far as the keep it burning is concerned. So those are the four elements required to have a fire that can keep burning. So most accelerants, which are common in arson investigations, are hydrocarbons in a gas state. So hydrocarbons are compounds that are made of only hydrogen and carbon, hence the name hydrogen, carbon. Some examples of these include gasoline, kerosene, lighter fluid, many more examples. The reason they are all in their gas state is molecular bonding is weaker at this state, meaning it's easier to break those bonds. Two more vocabulary words for you back at the beginning are vaporization, which is when liquid changes to gas, and flash point, which is the lowest temperature at which vaporization occurs. And we need vaporization to occur in order to get that accelerant to burn most effectively. Now, I'm not asking you to write down or memorize this chart, but I do want you to understand the relationship between flash point ignition temperature and as far as using these for accelerants. So as you can see, acetone and gasoline both have incredibly low flash points. They are in the negative numbers. However, acetone has a pretty high ignition temperature to light it on fire, making it not an ideal accelerant. Meanwhile, gasoline has a much lower ignition temperature, making it a pretty popular accelerant, both for its availability and for its ignition temperature. Kerosene, mineral spirits, and turpentine all have higher flash points, but still maintain that lower ignition temperature. So while it's going to take more for vaporization to occur, you can light them on fire at those same temperatures. So we want something that has a low flash point and a low ignition temperature as the ideal accelerant. Another vocabulary word for you is pyrolysis, and this is the decomposition of organic matter by high temperatures. This makes sense. The prefix pyro means flames and lysis means to break down, so high temperatures breaking something down makes sense. And you can see that occurring in this image, pyrolysis occurring in this image here. The decomposition area is what is below the flames. And the heat is sort of causing this feedback loop that causes it to keep going. The vapors given off from resins and wood are flammable and will burn. This is why house fires are so common, because there is so much wood in them. Now, fires themselves are not criminal unless you are violating the law by lighting a fire, and one of those ways is arson. Arson is a crime of setting a fire, and there are kind of a variety of things that go into that. The thing about arson is it is difficult to prove, and that is because the crime is usually carefully planned. Most people don't just wake up and decide to set a fire without a plan. Most arsonists carefully plan. The arsonist is able to leave the scene before anyone notices the fire. It's not like if you shoot someone, you had to be at that scene when the gun was fired. You could start a very small fire, leave the scene, and just wait for it to become big, and no one would know you were there. Additionally, fire destroys evidence. And if the fire didn't destroy the evidence, the process we have of extinguishing fires is very damaging to our evidence as well. And you can't collect evidence until the fire is out. So between the fire and the extinguishing process, a lot of evidence gets destroyed in the process. So this is where fire investigators come in. It is typically not crime scene investigators that investigate fires. It is fire investigators that are kind of like a crime scene investigator and a firefighter all mixed into one. So they are responsible, as their name implies, for investigating the fire. The investigation must begin quickly before evidence is lost. Essentially, as soon as the structure is deemed safe to enter, they are one of the first people in there trying to figure out what happened. They're looking to find the fire's point of origin, examine possible causes, and to classify the fire. Now we're going to talk about each of these things a little bit more. So when it comes to determining the cause of the fire, they are going to want to look for patterns that the fire makes. Depending on what happened, fire actually makes different patterns. This is something you probably didn't know. So fire can make different patterns depending on what caused that fire. You are responsible for knowing these patterns, descriptions, and indications. So we have the classic V, so named because it looks like a V. It's a burn pattern that is narrow at the bottom and spreads outward as it rises, like a V. This is an ordinary burn pattern. It typically means no accelerant was used. Meanwhile, an inverted cone is essentially an upside down classic V, where the burn pattern is wider along the floor and narrow as it burns upward. Now this can be caused by an accident. It does not have to mean an accelerant is used, but it can sometimes mean an accelerant was used because it means you had a large area burning all at one time as opposed to a small area. Again, it could be either. Then we have alligatoring. You have probably seen alligatoring if you've ever burned logs in a fire pit. And this is a burn pattern resembling the scales of an accelerant. This means that there's a possible use of an accelerant, but not absolute. It has to do with how hot the fire gets. If you have to get a fire pretty hot to get alligatoring, it used to be thought that we could only get a fire that hot with the use of accelerants, but now we know that it doesn't necessarily mean that. Spalling is essentially the same thing, but on concrete instead of wood, and it's the breaking away of layers of concrete due to exposures to high temperatures. Again, possible use of accelerant, but not absolute. It is related to the temperature. We also used to think you could only get spalling if an accelerant was used, but now we know that a fire could get hot enough without an accelerant. Then we have streamers, sometimes called trailers if you see on other sources. And this is a burn pattern that shows a trail, hence why they're sometimes called trailers, from one area to another. Most often this means an accelerant was used to spread fire from one area to another. Think of someone dragging a gas can behind them and pouring it as they go. Now there have been some cases where streamers or trailers have been found that it was not the use of an accelerant, but most often it is. Arc damage is a spark caused by a release of electricity. So this tells you had an electrical fire. May also be the result of a fire that burned through wire insulation. So if you already had a fire and it burned into the electric system, you can start seeing arc damage, or arc damage may have happened first, causing your fire. So you do have to kind of figure out which one occurred first. Then a pool, sometimes called a plant, and this is a burn pattern in a puddle configuration. Again, this most often means the use of an accelerant was poured into one location and then lit on fire. However, there have been a few cases where they found what looks like a pool and it was not an accelerant. Just some pictures for you. So we have that kind of classic V pattern here where we have an area and it's spreading upwards. We have our pool or plant looking area right here where it's all burnt in one location. We have our alligatoring where you can see it kind of looks like the scales of an alligator. We have our spalling where the concrete is actually breaking away. Again, these are both from high temperatures. Something a fire investigator also wants to find is the ignition source. Now, there are many different ignition sources out there. These are just a few of them. You could have matches. These can be a difficult ignition source to identify because matches typically burn up in the fire. They are just little sticks of wood. They're often gone. Cigarette lighters, oftentimes if an arsonist has chosen to use a cigarette lighter, they are going to take it with them, so it's not going to be left at the scene. Molotov cocktails are where you take a glass bottle and fill it with an accelerant, usually gasoline, and put a rag or some sort of fabric in the top and light that fabric on fire and then throw it, with the idea being the bottle will break and the flame will spread to the gasoline. This does leave glass fragments behind, but This is why, as we talked about in our glass unit, it's important to identify different types of glass so you could tell bottle glass from maybe window glass. Faulty electrical wiring in arc causes a predictable pattern, so you can find those burned wires and you can see the arc damage. And knowing the igniter is going to help form the criminal profile, which is the other part of our unit, but we are going to talk about it a little bit now. So when it comes to collecting evidence, fires are a little bit unique. Evidence collection can begin immediately in a fire. There is not a warrant required, unlike in other types of crimes where you do have to get a warrant. As long as the scene is still an active fire scene, you can go in and collect whatever evidence you need to without a warrant. Most of what's going to be collected is ash, collecting 3 to 4 liters of ash from the point of origin and other suspected areas. You can also use portable vapor detectors or sniffers that detect accelerant molecules in the air. There are also dogs who are trained to sniff accelerants. Another thing that needs to be collected aside from the evidence is what is called a control. So we're going to place each sample in their own container, and then we're going to collect a substrate control. And this is a debris sample that has not been contaminated by accelerants. So we're taking it from somewhere in our fire that we do not believe was exposed to accelerants so that we can compare it to samples that we think may have accelerants in them. The reason for this is sometimes people have things in their homes that look like accelerant but aren't. For example, a lot of couches burn very, very well because they're basically made of petroleum. So we have to collect other samples so we can see whether an accelerant was used or not, because if it is appearing in our control sample, that means we know accelerant wasn't used, but if it's not appearing in our control sample, that's going to help us prove accelerant was used. Now, when it comes to packaging the debris, we're going to use airtight containers. Most often, they use clean and new paint cans in their lids because they can get an airtight seal. Now, they do not fill them all the way to the top. They do leave what is called head space at the top of the can, which is a gap between where you have your ash and where you're going to seal the can. Now, there are 2 methods for analyzing the ash for accelerants. The first is called direct extraction procedure, and you're going to heat the debris container to collect vapors in the headspace, so we're heating that container. Then you essentially stab the lid with a syringe, suck all the gas out, and then we're going to put that gas into a gas chromatography machine for it to tell us what's in there. The second method you might think seems like not as fancy, but it does just as well and is often cheaper to do, so a lot of places still do this. So passive extraction procedure, you suspend a charcoal-coated strip inside the can, replace the lid, then you heat the container for 4 to 6 hours, 50 to 80 degrees Celsius, so not super hot. And then the charcoal actually absorbs the vapors, and then you can analyze that charcoal strip. If you're having trouble visualizing passive extraction, this is what it looks like. Pretty simple, but it gets the job done. Now, as we said, another thing a fire investigator has to do is find the point of origin or area of origin. So the point of origin is where the fire started. This is obviously important to identify because we need to know where the fire started to know what happened. This can sometimes be difficult though, depending on how much the fire burned. So sometimes we just have to settle for an area of origin, that we know it occurred in this room of the house, but we don't know where in that specific room. There can also be 1 or more points or areas of origin. That usually indicates that you have an arson fire, because the multiple fires randomly popping up is unlikely. The point or area of origin will be the place that is the most burnt, since that is where the fire started. It is also typically the lowest point of the fire. Not always. If someone started a fire on the 2nd floor of the house, it could burn downward, but typically it is the lowest place. So looking at this photo, things that you might notice when it comes to determine the area of origin or point of origin. So we might notice that the cabinets up here are covered in soot, but the cabinets down here are clean. That tells us that our fire started above this line, because otherwise these cabinets would have gotten burned. So we start looking for the most burnt area above that line, and we quickly see this ironing board that is very, very burnt. And it's right at that line that we start to see things be unburnt. So likely, this is a case that someone left an iron on and caused a big fire. Now, another thing a fire investigator does is they classify their fires, and they can fall into 4 categories. The first is natural. This is a fire caused by an act of nature, such as a lightning strike or really intense sunlight. Then we have accidental, which is a fire that was unintentional and explainable. Causes may include faulty wiring, malfunctioning appliances, human carelessness, like the leaving the iron on the ironing board example. So accidental was that a fire was not started initially and something accidentally made a fire start. Now, undetermined is that we cannot figure out that cause of the fire, and sometimes that happens. Now, the last one is the one that gets students, deliberate/incendiary. You're going to notice this is not called arson, and that's because arson is a specific type of crime. Deliberate versus incendiary is a fire that was intentionally set. So not all deliberate fires are arson. For example, if you have a campfire and you don't put it out properly, so it relights and then catches the whole forest on fire, that was a deliberate fire. You did deliberately set that fire. You didn't mean for it to burn the whole forest down, but you did deliberately start a fire in the first place. So not all deliberate fires are arson, but all deliberate fires, somebody did start a fire, whether they had criminal intentions or not. Now, obviously, when we're talking about forensics, we are talking about arsonists typically. So the psychology of an arsonist is an interest one. Most of them report liking setting fires because of the sense of power it gives them or the emotional high that it gives them. Now, while there is no typical arsonist, there have been a couple of characteristics that have become associated with arsonists. They are usually on the younger side, less than 25 years old. They often don't have a father in the home with them. Their mother is often more domineering and controlling. Oftentimes, arsonists were deemed academically challenged in school. This doesn't mean that they weren't smart, but it does mean that they didn't do well in school. Emotionally or psychologically disabled, they are typically kind of stunted in the emotional elements. They are often unmarried, living with their parents, express feelings of inadequacy and insecurity. They often have a fascination with fire. Many arsonists are alcoholics and suffered from parental neglect or abuse. Now, this is not necessarily a checklist, but these are characteristics that we do see occurring with arsonists with more frequency. So why does someone commit arson? There are 6 recognized motives for arson. That is financial gain. So an example of financial gain would be, say, you have to have home insurance on your house. You no longer want your house. Maybe you're behind on the mortgage, or you want to move but don't want to go through the process of having to sell your house and everything because you know it's not in a position to sell. So you light your house on fire and you collect that insurance money for your house. You have gained financially. Revenge or spite. Revenge or spite is when someone sets something on fire to get back at someone else. Their fire investigator once told me a story about a case where he investigated one neighbor had borrowed the other neighbor's tools and never returned them, so the first neighbor lit their house on fire. That would be revenge, I guess. Excitement, setting a fire because you like the way it makes you feel. You commit arson not because you have anything to gain, you just like how it makes you feel. Vanity or hero syndrome, this is the one that troubles people the most. There is not a small number of arsonists that are actually EMTs or firefighters, and they set the fire, then go back to the firehouse or go back to the hospital or whatever, and sit and wait till the fire gets big enough that a call comes in. Then they get to ride in on the fire truck and put out the fire, and everyone tells them what a hero they are and what a good job they did. And it's messed up, but it's one of the motives of arson. Crime concealment. Common one is that someone has been murdered, and whoever murdered them tries to light the whole house on fire to both cover up the murder and to burn the body. Pro tips: most fires have to get ridiculously hot to actually burn a body, so it's not also pretty successful. And as that same fire investigator from the earlier story has told me, arson actually carries a pretty hefty prison sentence, so make sure whatever crime you're trying to cover up is a more severe crime than the arson. Otherwise, if they can prove the arson, you're going to jail for a long time for what was originally a small crime. And then last but not least, we have vandalism, like setting a local store on fire just to do it. Doesn't necessarily excite you, but you just want to burn some things down. So that is our summary of our arson. Looking forward to talking to you more about it in class.